the literal truth. He believed that the sun really was in the center. It wasn't just an elegant model. The sun really belonged in the center. That really was it. The earth really was moving. But as I say, he couldn't really prove this. The evidence that Galileo had that the earth was in motion consisted, for example, of arguing from the evidence from the tides. Of course, we know the waves at the ocean. He argued that the reason that we see waves at the ocean is that the earth is both rotating and it's revolving. So it rotates and it goes around the sun, and the result of all this is it's shaking up the water and creating the waves in the ocean. Well, if that sounds like a silly explanation, that's because it is. So people didn't necessarily buy that. But meanwhile, Galileo was walking around claiming that all biblical verses that make it sound as if the earth is motionless need to be reinterpreted. This was the problem. Can a layman just run around demanding the reinterpretation of biblical verses on the basis of a scientific theory that he can't even prove? And this was at a time, remember, when the Protestant Reformation was not exactly yet a distant memory. And Protestants were always hounding the Catholic Church for not giving the Bible its due and not listening to the Bible enough. So here's Galileo going around saying the Bible's got to be reinterpreted. So let's come back and try and make sense of what ended up happening to Galileo and who was right and who was wrong. Welcome back to the Catholic Church, Builder of Civilization. I'm Thomas Woods. We're talking about Galileo, and before the break we noted that Galileo believed very passionately in the Copernican model, by which he meant that the sun was at the center of our solar system, so to speak, and that the Earth was one of the planets that orbited it. But as I also suggest, that he did not have ironclad proof of that by any means. And if you talk to any historian of science who knows anything about the 17th century, he will tell you that the geocentrists, those who disagreed with Galileo and put the Earth at the center, still had a very good and reasonable scientific argument. And I want to amplify that point and just show that it wasn't a question of complete morons irrationally opposing Galileo, and Galileo being a wonderful genius who has to tolerate all these stupid ignoramuses. To the contrary, they had extremely good arguments that he could not answer. The main argument involved something called stellar parallax. Now that sounds very complicated, but you'll be amazed at how simple it is. Let's first just look at that word parallax. This is a phenomenon that we're all familiar with. We see it every day. Parallax shift works as follows. Let's suppose, for lack of a better prop, that this candle is my mother, and I'm on a merry-go-round as a child, and I'm looking at my mother watch me go around the merry-go-round. And let's suppose that over in the distance there's a tree over here. But let's say that over here there's a hot dog stand. So here I am, I'm going on the merry-go-round, and I'm looking at Mom, and I'm waving, and when I get to this part of the merry-go-round and I look at her, I see her against the tree. But when I get to this part and I look at her from this angle, I see her against the merry-go-round. Well, I don't say to my mother, hey, how come you're shifting around while I'm on the merry-go-round? I just know that in each case it's because I'm looking at her from a different angle. When I look at her from this angle, I see her against the tree. When I look at her from this angle, I see her against the hot dog stand. This is called a parallax shift. It's why if you look at a close-up object against a background, and you look at it with one eye, and then you look at it with the other eye, it seems to shift against the background. It's not because the object is actually moving, it's that you're looking at that object from a slightly different angle when you look at it from either of your eyes. Now, stellar parallax simply means a parallax shift that involves stars. And here, I'm going to refer you now to this diagram. What we see here in the diagram, you'll see on the left-hand side there are two human eyes. A little disturbing, but just work with me here. Look at the top eye in the upper left-hand corner. When that eye is looking at the object in the middle is that yellow star. From that angle, it sees the yellow star against the blue background at the lower right of the diagram. Now let's look at the bottom eye. In the lower left corner, we see the bottom human eye. When it looks up at the object, it sees it against the red background. So the apparent shifting of that object is the parallax shift. Now let's look at our second diagram. This one is portraying outer space. And here, instead of two human eyes, we have two solid circles. The top solid circle is the Earth on, let's say, January 1st. The bottom one is 6 months later, when the Earth has gone halfway around the Sun. Now, what's going on here? Well, notice that, again, we have a closer-up object and some farther away objects. In the case of my merry-go-round example, my mother was the close-up object, and the tree and the hot dog stand were farther away. Here, we have a closer-up star, and then we have stars that are farther away. Now, on January 1st, when we look at that close-up star, we see it against the background of other stars more in the distance. Now, 6 months later, when we look back at that star, we're looking at it from another angle, so we're going to see it against a different background of stars. In other words, in the same way that my mother seems to shift, depending on where I am on the merry-go-round, close-up stars are going to seem to shift depending on where we are on the Earth's orbit around the Sun. So we should see a parallax shift. We should see the closer-up stars appearing to move against the background of the farther-away stars. Okay, that's the end of the diagram segment today. Well, what does this all boil down to? It boils down to this: that in fact, at that time in the 17th century, geocentrists were making that argument. They were saying, okay, Galileo, if you're so sure the Earth is going around the Sun, how come we don't see parallax shifts? Now, that's not a stupid argument, is it? Does that sound like a dumb guy argument? That's a very sophisticated argument, isn't it? But Galileo had no answer for that. And again, the Church's attitude was, if you can't prove to us that this is absolutely true, then the best we can do for you is say you can use it as a theory, but you certainly can't go around saying, well, the whole Bible needs to be revisited and reinterpreted. You can't do that till you prove it. And as I say, it had not been proven. The stellar parallax question had not been dealt with. And in fact, it wasn't until a very long time afterward that we got sensitive enough equipment to be able to detect the parallax shift. It is there. But the distances involved, with the stars being so far away from us, were so much greater than anyone thought. No one had any idea they'd be so far away. No one realized that the parallax shift would be so tiny because of the distances involved. It looked as if there were no parallax shift, and so therefore the Earth is motionless. So I think that's important, just as a matter of justice, to point out that these were not just stupid heads. That's a serious objection to Galileo. Now, Galileo refuses the compromise that's offered to him, whereby you can teach this as a theory, but at this point, it has not been proven. And again, the Church, as I said, is sensitive to Protestant charges that Catholics aren't paying proper regard to the Bible, so you have all these factors at work. Cardinal Robert Bellarmine said, look, if there were a real proof that the Sun is in the center of the universe, that the Earth is in the third heaven, and that the Sun does not go round the Earth, but the Earth round the Sun, then we should have to proceed with great circumspection in explaining passages of Scripture which appear to teach the contrary, and rather admit that we did not understand them than declare an opinion to be false which is proved to be true. But he said, as for myself, I shall not believe that there are such proofs until they are shown to me. Well, that's not a crazy position to hold, it seems to me. In 1624, Galileo was again received with great enthusiasm in Rome. The Pope told him that the Church had never declared Copernicanism to be a heresy and would never do so. And the Pope decided to hang on to this idea that Galileo could continue to teach what he wanted to teach as long as it was in the realm of theory, until such time, if ever, it should become established firmly as fact. Well, Galileo broke the rules. In 1632, he wrote his Dialogue on the Great World Systems. And in this work, he does not, in fact, stick to the idea that the Sun being at the center is a mere theory. He suggests that it's a fact. But worse than that was that Galileo wrote this dialogue as a dialogue. And one of the characters in this dialogue